Below, we'll look at several practical sampling techniques. The first type is called systematic sampling. This is where a sample is obtained by drawing every nth population member from a list or production line. An example would be lining up people of a certain population and then just selecting every fourth member. Cluster sampling consists of a random selection of groups or units, often called area sampling when applied on a geographical basis. After dividing an area into sections called clusters, a number of the clusters will be randomly selected. Then either all the members of the selected clusters will be used in your sample, or you could take a simple random sample from each of those clusters. For example, let's assume 5 of New York's 62 counties are going to be chosen at random. They could be the ones that are colored in red here. To complete the cluster sampling, either every member of those selected counties would be included in the sample, or you could take a random sample from those counties only and include that in your sample. An advantage to cluster samples is that they're easier to obtain than some other methods and the costs are often lower. A disadvantage, though, would be less precision than the simple random and stratified types of samples. Stratified sampling is dividing a population into parts called strata for the purposes of drawing a sample. The characteristics used to divide the population are called the stratifying factors. Common examples could be gender, race, religion, income, etc. A simple random sample is often chosen from each stratum or class. Stratified sampling ensures that members of each group within the population will be sampled. An advantage is high precision with low numbers of data pieces. For example, let's say that 2 randomly selected boys and 2 randomly selected girls are chosen to form a stratified sample. As you can see in the picture here, the same number of individuals is chosen from each category. So here the stratifying factor could be sex or gender. It is well known in the field of biology that different sexes can exhibit a phenomenon called dimorphism, which means each sex tends to have different averages of some measurable characteristics. In which of the cases below would it be useful to use sex as a stratifying factor? What if we were trying to estimate the average weight of a population of all polar bears? But polar bears are among the most sexually dimorphic of all mammals. Males may average 1,000 pounds in weight and females may average around 500 pounds, so there's a big difference there. Would it be useful to use stratified sampling in order to be sure that both sexes are equally represented here? I would say yes, because they would have different weights. If we got a abnormally large proportion of males versus females, then our average of the weight would be skewed in that way. So I would say yes for that one. What about trying to estimate the average height of the population of all adult humans? Would it be useful to make sure that both males and females are represented so we can get a good average between them? I would say yes. What about trying to find the proportion or percentage of all adult humans that are female? For this one, I would actually say no, because when you're trying to find out the proportion of females versus males, you wouldn't want to pick the same number of individuals from each group, or else you would get 50%. So we don't want to use stratifying sampling in that case. Finally, convenience sampling uses the most easily available data. It may be all the information that's available, and it could be useful, better than nothing at all, but it can also often be highly biased.